Hello, everyone. Welcome to episode 18 of the Current Review podcast. Today, we have on an extremely exciting guest. His name is John Kelly, and he is a professor at Weber State, where he is an automotive professor. He does tons of teardowns of electric vehicles on his YouTube channel, which is it the Weber State automotive program?
It's Weber Auto, all one
Weber
word.
Auto.
Yeah.
Okay, perfect. And you have just a plethora of knowledge about electric vehicles. I think you've torn down a Mustang Mach-E, Chevy Bolt, plenty of other vehicles. It's really awesome, so please check it out. And without further ado, I just want to ask you the first really big question. With your time just taking apart these various electric vehicles, what are some interesting innovations that you've seen arise within the past 10 to 15 years?
Well, it's been interesting to see the evolution of things that have happened in these vehicles. My own vehicles, I started with a Toyota Camry hybrid that back in 2007 when they just came out. It was my first hybrid, and I really loved it, and it was really cool. Then along came other vehicles. I ended up getting a 2010 Prius when they came out, and its technology was even better and better fuel economy. And then Chevrolet came out with the Volt, and I thought, I don't know if I trust that. So I ended up leasing a 2012 Volt for 3 years, and my wife and I just totally loved it. Wanted to buy it at the end of the lease, but the lease buyout was more than the cost of a new one because of the $7,500 tax. Yeah, it's like, no, you can have our old one. We'll just buy a new one. But in looking at the evolution from the hybrid systems to plug-in hybrids to battery electric vehicles, for us driving the vehicles, the hybrid vehicle was really fun, and my wife and I would have competitions to see who could get the best fuel economy, and she always won because she's a little tiny lady and and I'm not. But anyway, the 2010 Prius came with this gimmick. It had an EV button, and so you push that button, and as long as you didn't go faster than 25 miles an hour or didn't accelerate very fast, it would drive on electric power only. And we could go, I don't know, half a city block before the engine turned on, and we were all impressed. Ooh, wow. And so that kind of got us interested in the plug-in hybrid technology. And the Volt, when it came out, as you mentioned in one of your postings the other day, was really a very impressive car.
Even by today's standards.
Yes. The original Chevrolet Volt that we bought had a 38-mile driving range on electric power only, and then would switch to hybrid mode, which it easily got 40 miles a gallon after that. And that was very impressive. But anyone who's driven a plug-in hybrid and driven around in electric vehicle mode ends up usually liking it. And when the engine comes on, it's like, oh, what's that noise? And you almost get irritated that you have to have the engine on. At least we did. So then the Chevrolet Bolt EV came out before the Model 3 from Tesla came out, and so we ended up getting a Bolt also, and really liked that. And then we've had a Tesla Model 3 and a Model Y, and I just recently bought a Cybertruck.
Wow!
But in looking at all of those, I mentioned an evolution. So the Chevrolet Volt, being a plug-in hybrid, had an internal combustion engine to back things up if your battery level got low enough that the engine needed to start, then so what? You just keep driving, and there wasn't the range anxiety that some people are concerned with today. It just depends on how are you using the vehicle. For me, I had a 15-mile drive to work and back, and I could drive for 6 months or so before the engine even forced itself to come on because it hadn't been used. But that was a great commuter car. But uh, evolutionary things, such as, for example, the heating systems, have been very interesting to me. I've got behind me here on some workbenches, I've got a mock-up of three different, well now four. I've got the Cybertruck system. I've ordered all the parts and putting it all together on a bench. But the original Volt and the Bolt EV, to replace the internal combustion engine as a source of heat, they had to use an electric coolant heater, a positive temperature coefficient coolant heater, PTC coolant heater. And it was very inefficient. It easily used 7,500 watts of power to heat the coolant for the passenger compartment. So they still kept, just imagine a heating system from 75 years ago. You got a heater core, you got heater hoses, you've got a belt-driven water pump, and all they did in this early step of evolution was to replace the belt-driven water pump with an electric water pump, and replace the internal combustion engine as the source of heat energy with this PTC heater for the coolant. In the wintertime, in the Volt and the Bolt, there's a significant loss of driving range. In the Volt, it could easily be half of the driving range, and if it was cold enough, didn't matter how low or how charged the battery was, the engine would come on anyway because the electric heater couldn't provide enough heat energy to heat the cabin. And that's just the cabin. Then we still had to heat the battery. And so the Volt and the Bolt both have dedicated electric resistive type coolant heaters for the batteries. You could have in the wintertime, and both of these were great cars, but this is early stuff. They had an electric heater for the cabin, an electric heater that on the Bolt EV that I still have down here on the hoist, it can be another 6,000 watts at the same time that you're drawing 7,500 watts for the cabin coolant. So now you've got 13,500 watts for heating the battery and heating the passenger compartment. And then you've got an air conditioning compressor that comes on if you want to have dehumidification, depending on the temperature and the humidity in the air, because you don't want to blow moisture up on the inside of the windshield when it's cold, because you'll get frost on the inside of the windshield. So now you've got an air conditioning compressor that could draw anywhere from another 1 to 2.5 kilowatts of power. So in the winter
That's really interesting because I think people that I've talked to, especially up in the northern areas, assume that it's because of battery chemistries that EVs are less efficient in the winter. But that's not the case at all. It's really driven by temperature and to some extent creature comfort inside the cabin.
It is,
right?
and I've done a lot of experiments here in the over the years and with these classes, and I have this thing I teach in my classes. I call it the 1 degree difference. So I like to poke fun at my wife, and she puts up with it. But if she's cold and gets in the car, she turns the temperature all the way to maximum hot. Now, with a vehicle with an internal combustion engine, so what? That's not going to warm the engine up any faster. It makes her feel better, but you could turn it to 80, and it would still reach 80 just as quickly as if you reached or had turned it all the way to maximum hot. But in electric vehicles, that is not the case. If you get in a plug-in hybrid or a full battery electric vehicle, and you set the temperature all the way to maximum hot, these vehicles will give you as much heat as quickly as they can, and the energy usage is just outrageous. And the experiments that I've done show that if you, instead of picking maximum hot, you go to maximum hot and then back it off 1 degree, then the energy use goes way down. You still get warmed up more quickly, but you don't end up losing as much driving range. Some of these cars will give you 165-degree air if you wanted, if you turn it all the way to maximum hot. And nobody wants 165, but they're trying to give you that because you've selected, give me all the heat you can. And I have to, I'm a member of many Facebook groups and other social media groups, and I don't really write or post much in those groups, but I'm there to watch what other people are complaining about or what they're experiencing. And I grab screenshots and stuff. And it's been kind of interesting to see a lot of people who are complaining about driving range. They'll show a picture of their instrument panel or whatever, and their heat is all the way to the max. And the same thing for air conditioning. If you go all the way to maximum cold, that's going to use more power on these vehicles than maximum cold plus 1 degree. And if you come to these classes that I teach here, you'll get to experience that yourself and see what a huge difference it makes. And it depends on the vehicle manufacturer too. But as things have evolved, I mean, that was the first early types of heating systems. And unfortunately, there are newer vehicles out there today that if they don't have a heat pump, that's what they're still using. And you can buy a brand new vehicle today that still has that old technology in it. And just because it's new doesn't mean it's up to date. As vehicles like the Nissan Leaf initially, the first 2 years of the Nissan Leaf had a PTC coolant heater. And it only had a 21 kilowatt hour battery. And you could easily lose half the driving range. And so in 2013, the Leaf picked up a heat pump, and that reduced the impact on the driving range. It's kind of fun to watch on the Leaf that we have here, that as you change temperature, it'll tell you how many miles you're losing. I wish other companies would do something similar to that, but
yeah, I love that feature that when if I forgot what cars, because I've driven a fair amount. I think the Kia EV6 and Hyundai Ioniq 5 are like that, where depending on how much, what your temperature is and what your fan speed is, it adjusts the range that you see on the car, which is really cool. But some cars, this one is like my big pet peeve. It's the Subaru Solterra and Toyota BZ4X. The minute you turn on the fan, regardless of the AC, heat, whatever, if you have the fan on, it will immediately take 40 miles off your indicated range. But it doesn't matter what the fan speed is. It just matters if the fan is on. And I'm like, this is so crazy.
Oh,
yeah.
Interesting.
Well, that just goes to show you how much thought they put into in terms of engineering, I think, right? And integrating the systems. Like they just did a blanket, if the fan, very basic controls logic of if the fan's on, subtract 40 miles, which is not very sophisticated. We know that we can do better than that, right? So yeah, that's crazy. It's interesting to me overall, heat pumps have been around for a while, but it's taken a while to get into vehicles, and more specifically EVs. For instance, I know I just went from a Gen 1 to a Gen 2 Rivian, and one of the big changes is they went to a heat pump.
Yeah.
And there's there's only a 2-year difference between the vehicles, right? And I will say, it does do better in some respects. I think they're still figuring out some software things because it jumps all over the place when you're in auto trying to find optimum conditions to run that, and it wreaks havoc on the range right now. I trust they will figure it out because it's a software thing. But I don't know. I'd be curious to hear from your perspective, John, of how long has it taken for? I mean, it's still being adopted, heat pumps, and why is it? Do you think that it's taken so long for automotive and EV specifically to adopt heat pumps?
Well, first, let me tell you, the Saturn EV1, when it came out, had a heat pump.
Good.
So clear back then. I have a full set of service manuals for it, and I was reading through and thought, what? So,
That's crazy. Advanced
yeah.
technology in a Saturn.
So the technology has been there, but the problem with heat pumps is they work really well down to a certain temperature, and then below that you have to supplement heat energy from some other source. And so just because a vehicle has a heat pump doesn't mean that it's the same as the heat pump in another vehicle. So, for example, the early EV1 from Saturn that GM leased and took back and crushed and all that stuff, they would to get extra heat, they would just apply a higher voltage to the air conditioning compressor that would make its windings get hotter, and then that would transfer heat energy into the refrigerant that they were compressing, which was actually a pretty good idea at the time. But that was, from what I've read, that was how they would get extra heat energy when you couldn't pull it out of the air because the outside temperature was too cold. But as you mentioned, there's electric vehicles operating all over the world in very cold climates, and so some heat pump systems still have the old PTC coolant heater. I have over here on the bench. I just barely purchased them. The drive units from a Blazer EV and the Cadillac Lyric, and I was really surprised on both of those because they both have heat pumps to find it still has a PTC coolant heater, and I'm pretty sure that's there as a backup or not a backup but a supplement for when the coolant temperature gets, or the outside air temperature gets low enough. And it's really the battery temperature that we're talking about there, because that's the battery's your heat energy reservoir that we're trying to transfer some of that heat energy from. But there's differences in heat pumps, and so there are the ways of supplementing the extra heat energy are electric, like I just told you on the new Blazer EV, the Equinox, the Honda version of that, and Cadillac Lyric, and so on. Even the full size truck, the Hummer with a new set of sheet metal on it, the Chevy
Silverado.
Yeah. They still have an electric heater there with the heat pump, but there are other systems. For example, Tesla's heat pump system, they claim works clear down to minus 40 Fahrenheit and Celsius, same temperature, and everybody has to have a method of supplementing heat, because you can only pull so much heat energy from the air, which is the typical way of doing it. But instead of having a dedicated coolant heater, they use the drive units. So behind me here, I've got a stator right there, a 3-phase stator from the drive unit of a Model 3. And one of the ways that they heat coolant without having to have a dedicated heater is to run that stator at a hotter temperature than it normally would be. So they purposely make it run inefficiently. So normally everybody's trying to get the maximum efficiency so they're not wasting energy, so you can drive farther down the road. But what if you purposely made it inefficient? Well, then that inefficiency translates into heat energy. So they're transferring heat energy into the transmission fluid, the oil that's in these drive units, and then there's a heat exchanger that gets transferred into the coolant that goes into the battery. And so they're using existing parts and to add additional heat energy, and that's really neat. They
That's
don't.
really interesting. That's like innovation at work right there, right? Like it's
Yeah,
almost like EV technology went too far with the efficiency, right? Like you've got gas over here, EVs way over here, and now they're trying to find interesting ways to transfer the inefficiencies to make these other systems work that they forgot about, right?
right. Yeah. What an interesting thing I've read about on the Cybertruck that I just bought is that there's possibility of snow accumulating on the LED headlights.
Yeah.
They don't put out any heat or much heat to speak of, so it wouldn't surprise me that they come up with some way to just make them run a little hotter than they normally would, without having to add a heater or something like that. I don't know. But different companies come up with different ideas of ways to eliminate parts and accomplish multiple things with the same piece. And so the drive units is just one of many methods that or sources that you can get additional heat energy to supplement and add to the refrigerant that is used in the heat pump system. Because the whole idea of a heat pump system is to add as much heat energy as you can to the refrigerant, and then you compress it. It gets even hotter, and then you run that through an inside condenser inside the passenger compartment and transfer that into the air. And so anywhere on the vehicle, you can grab that extra heat energy, and you've got to get it into the refrigerant first, and then it'll warm the passenger compartment. So I have five different vehicles with heat pumps here, and they are not all the same. They don't all have the same efficiencies. They don't all operate down to the same temperatures, outside temperatures. But heating and air conditioning has been one way that I've seen a lot of evolution, and very interesting evolution. I mean, that was the thing that finally made me sell my Chevrolet Bolt EV after the battery recall. I was not too thrilled about that, but and get a Tesla Model Y. And so my wife is driving a Model Y that I used to drive, and now I've got the Cybertruck. But it was the heat pump that was the final thing that made me just be totally amazed and say I got to get one of these and experience it. And it was kind of, I don't know how good of an idea it was, because my Bolt was all paid off. I didn't want to buy any more cars, but dang it, they keep coming up with cool technologies, and it's like, oh. And then the Cybertruck came out with the 800 volt system and the 48 volt system. I was like, oh no. So now I need to experience that. And I would have purchased one through the school, have the school purchase it, but Tesla does not have a way for you to purchase a vehicle unless you use their payment method.
Mm.
So our school
like a personal like payment method almost, right?
Yeah.
Not like an organizational one. That's weird.
Our organization needs to send a requisition and then get an invoice, and then we send them a check. And no, they don't do any of that. So Tesla does not do that. So I thought, I'm going to get rid of the Model 3 that I had and trade it for the Cybertruck, and that's when they had the transfer your full self-driving software.
Nice.
So
that's
I'm
cool.
able to check that out. But
nice.
They've had efficiencies. I just did a video the other day and released it on the low voltage charging systems on. It was a Prius Prime, a 2024 Prius Prime that we have over here, and that's another area where there's been a lot of evolution over the years. My first Chevrolet Volt had an air-cooled DC to DC converter, and that's the part that takes the high voltage and steps it down to the low voltage and replaces the alternator of a internal combustion engine vehicle. And I've got vehicles here in the shop that have 87% efficiency. You can calculate the power in, calculate the power out, do the math, and it's 87% efficient. Yet I've got newer vehicles that are 96% efficient. A vehicle that had a And that's just the DC to DC converter. We're talking about all the electronics that you see that are involved in running the car. If you can increase the efficiencies, then you don't need a 200 kilowatt hour battery. You can get by with a 150 or a 123 or a smaller battery, which is lighter weight. If you're 87% efficient versus 96, then that's heat energy. You're losing electrical energy to heat energy, and it's just having to be radiated out into the air through your cooling system. And so just by making high voltage electronics and low voltage electronics more efficient, you're increasing the driving range of the vehicle without having to have any bigger battery or better chemistry. And of course, all of that comes and goes, but the efficiencies, if you can get these things to run more efficient. And so one of the things that we do in these classes is to measure the efficiency of the things that we can, and look at how on some of the older vehicles, they weren't quite as efficient as some of the newer vehicles are today.
What would you say with all these sort of rapid improvements, which are really cool to see, in getting more efficiency and finding different ways to, say, transfer heat from the super efficient EV motor to other parts and other systems? What does it do in terms of being able to work on the cars, like repair and maintenance, as well as like longevity? Because you could also make, it's becoming more of a computer on wheels. Yeah. And people don't realize, but computers also degrade over time, right? The chips start to wear, you lose efficiency. And so some of those gains that you're making early on with these innovations, A, might be harder to work on, and B, they might not last as long. What do you think about that? Like, are you seeing that, or is that not really true?
I guess I'm really not seeing that right now. Mm-hmm. I'm sure there's cases where that will happen or eventually. One of the things that you need to be careful of is what people see as the perceived maintenance of these vehicles. A lot of people think there's no maintenance. I see people posting all the time with a bottle of windshield washer fluid. I'm doing my yearly maintenance. It's like, you haven't even looked at the owner's manual, because there's a lot of maintenance on these cars. Depending on the vehicle manufacturer, there's a 5-year or 150,000 miles, whichever comes first, cooling system replacements. So the Chevrolets that we have here, that's exactly what they have. But if people think that they don't have any type of maintenance required, and you just drive and drive and drive, then the coolant goes bad. It reacts with the metals, and corrosion starts to build up. And all of these electronics that are running nice and efficient when they're new, they have heat sinks, they have cooling fins. So as they need to transfer that heat energy from the electronics into the coolant. But if people don't do the maintenance when they should, then the corrosion builds up and it's not able to transfer as much heat energy out of the electronics. And of course, they'll run hotter, and that could lead to premature failure as well.
Interesting. Now, earlier, this is a total side note, and you mentioned the Prius Prime, and I really like plug-in hybrids. Like yourself, I used to have a Chevy Volt as well, and I think it was one of the coolest vehicles around, and I really like it. Really wish it wasn't discontinued, and it probably should be marketed better.
That really irritated me.
Yeah. And I think the huge thing is, and this is I would love you to explain the differences between the three main types of hybrids, which are series parallel, and that's kind of like because I believe the Chevy Volt could operate in both series and parallel mode, and then
depends on the year. Yeah.
Okay, and then just a regular parallel hybrid. So yeah, I guess first, yeah. Okay.
Yeah, that's a topic we cover, and I have every type of those here in my shop. The most common one that people probably are the most familiar with are Toyota products. So the majority of Toyota products especially front-wheel drive vehicles, are what are known as, well, Toyota themselves called it a power split hybrid. This is sometimes they call it a series parallel hybrid system, but it has two electric motors in the drive unit, and one motor, if it rotates, the vehicle moves down the road. The other motor is used in conjunction with a planetary gear set to create a variable gear ratio with respect to the engine crankshaft speed. So we can have the engine contributing torque to the what's known as MG2, the large electric motor that drives the vehicle down the road. We can have the engine helping that MG2 at different gear ratios. It's kind of known as an electronic continuously variable transmission, and that's because we can actually have underdrive gear ratios, direct drive, and overdrive gear ratios in this series parallel or power split, as the SAE calls it. Toyota, in their transmission, they actually have what's called a power split gear set, which is where it's two methods of supplying power to the wheels at the same time in this transmission. So,
and that would be an ECVT, correct?
ECVT, yes.
Because like you see that sometimes like on cars.com when you're looking for vehicles, and it's like
yes.
engine, and then someone at the dealership just put an ECVT because they didn't really know what it meant.
Yeah. Yeah, and that's a huge, but usually those are very reliable, last a very long time, unlike the CVTs that have a push belt or a pull chain in them that are horribly unreliable. But the ECVT since it's just two electric motors and planetary gear set, there's hardly anything to fail in there. So they work really well. It's been really reliable and good for Toyota products. It does have some limitations as far as power. We've had fleet like the state of Utah here. They tried to use some Toyota hybrids for police vehicles, and they found that the power split hybrid system just didn't have the torque that they needed to, in certain situations, like if you try to drive up over a curb from the road to up over a curb for whatever reason, unless you got a running start at it, it's not going to pull itself up over the curb.
Wow.
The engine will just rev up and it'll just sit there.
Interesting. Yeah, because on that note real quick, I'm really curious because whenever I look at like the specs of various hybrids, whenever I'm like writing a story or something, I'll see like the Toyota Corolla hybrid, which is an example of one, and it actually makes less horsepower and less torque than the sole gas-powered version. I'm sure they have different engines and whatever, but it's really interesting because you have some like especially totally different, but like plug-in hybrids like the Chevy Volt that make insane torque. That thing makes like 294 foot-pounds of torque, whereas like the Toyota Corolla hybrid makes like barely like 117. That's probably not correct, but it's really low compared to. So I'm curious about that.
Why is it?
Yeah.
Well, because the electric motor, the MG2 that makes the vehicle move, is a fairly small motor.
Yeah.
It's relatively speaking, compared to say the Chevrolet Volt. Its transaxle had two electric motors in them too, but they were much larger, wider, taller, easier torque since they have more leverage being a larger diameter electric motor. The Prius ones and the Toyota Power Split ones are some pretty small, inefficient. Well, they're efficient, and they're very efficient. I shouldn't have said inefficient, but they got rid of all the neodymium permanent magnets years ago, and have gone to some weaker magnets. And to make up for the loss of the magnetic strength from the permanent magnets, they have to spin these rotors at higher speeds to get the same torque. But if you're stopped, you're relying on a permanent magnet rotor that doesn't have very strong magnets in it. I'm sure is part of the problem. But Toyota has just recently, in the last I forget, 4 or 5 years now, introduced a parallel hybrid system in I believe the Tundra was the first one to have it, and now the Tacoma, Sequoia, the Land Cruiser, anything Forerunner, that is anything that's truck related or large SUV related now. And there's even a passenger car. I think it's the Crown, has a parallel hybrid system in it. And a parallel hybrid only has one electric motor. So the parallel hybrid has usually a much larger diameter electric motor, and it's sandwiched in between the engine and the transmission. Just think of it as a sandwich that's in there, and it can be connected directly to the engine crankshaft. And so on the old Honda Civic hybrids from years ago, they were called integrated motor assist systems, IMA systems, and they were parallel hybrids, and their motor was bolted directly to the crankshaft. You could not disconnect it. But all the new modern parallel hybrids, there's a clutch pack, automatic transmission style clutch pack, multi-disc clutch pack, that you can disconnect or decouple the engine crankshaft from the electric motor. But the whole point of that motor is to help the engine, it supplement it, give it some additional power when it's coupled to the crankshaft. But you can also disconnect it from the engine and have the engine crankshaft totally stopped, engine off, and have the electric motor driving the input shaft of the automatic transmission and move you down the road. So it's a totally different design of hybrid than the power split system that we discussed earlier, that's been around for a long time, and so is the parallel. But Toyota hasn't used it here in the United States anyway until just the last, I forget when the parallel hybrid Tundra came out. But almost anything rear-wheel drive or four-wheel drive you get today from Toyota that's not a crossover with a transverse mounted engine will have this parallel hybrid system in it. And so we've talked about a series parallel hybrid, which is what the Toyota Prius and all the other variations of that transaxle use, with the two electric motors. And then the parallel hybrid, it just has the one electric motor that helps the engine crankshaft rotate. And then the other one is what's called a series hybrid. And the Chevrolet Volt, the first generation Chevrolet Volt that came out in 2011 through 2015, it had it had a transmission that had 4 modes of operation. And the first 2 modes were all electric, running on battery power. The third mode was what's called series. And series mode is where the internal combustion engine turns on, and all it does is it turns an electric generator. It turns one of the motors that acts as a generator, and it's not coupled. It's not connected to the wheels. It doesn't propel the vehicle down the road. And by spinning that electric motor, it becomes a generator that supplies power to the other electric motor. So the Volt had 2 electric motors. So the engine crankshafts would spin one as a generator and then provide power to the other one through that generator. It could, if you put it in a certain mode, recharge the battery, but that's not something that usually is a good idea as you're driving down the road, because you only have so many battery cycles. Why, as you're going on a long trip, why would you want to charge it up, run it down, charge it up, run it down, when you could just, on a long trip, keep the engine running and keep it in series mode?
Is that the type of system that you believe a lot of these new range extended EVs like the Ram Charger and the Scout are going to use?
Yes. Yeah. The Ram has a pretty good size engine. I think a 3.6 liter engine, from what I've read, driving a generator, and it is not connected to the front or rear drive units. It's wires. So it's just turning a generator provides power to the front and rear motors as necessary. They're probably running off of just one drive unit, which is another evolutionary thing. Over the years, if you have an all-wheel drive vehicle, it's not using both motors in most cases. Most of the time, you don't need two motors to drive down a flat, dry freeway. You don't even need 1,000 horsepower to do that. You need like 30. Then, of course, the Ram truck is supposed to have a large battery also to drive on battery power only. But that's a series hybrid. Series hybrids have traditionally had a weak point, and that is if you load the vehicle, if you really load it up with all the weight it can handle or even more, and are driving pretty fast and they have to drive up a mountain pass or whatever, the generator may not be able to give you all the power that you need to maintain the vehicle speed that you want to have. And so then the vehicle starts to slow down. Chevrolet denied when the Volt first came out that the engine would ever couple to the transmission, but it actually does. It has a clutch back in there that they finally admitted could connect the engine crankshaft directly to the transmission and drive the vehicle under those conditions. But it's
so
not
it was like emergency backup. If you're going up a mountain,
yes.
And,
so
and you're starting to slow down.
Yeah. So any Honda hybrid that's out there uses a series, a 3-mode series hybrid type transmission. The Honda Accord, the Civic, and so on. They also are series hybrid. They have an EV mode up to a certain driving range or a certain vehicle speed, and then it runs in series mode. And then it also has a clutch that will only come on at higher vehicle speeds to connect the engine crankshaft directly to the final drive and provide power to move the vehicle down the road.
I mean, that's really interesting because with the new Ram Charger and the Scouts, the range extended versions are really, really popular. And in part because from what I've heard from a lot of people who've pre-ordered these, is because they plan to tow, right? Yeah. And they need the extended range to tow. But you're saying those are the conditions in which these series hybrids kind of have issues, right?
Historically, they've had issues. So we'll see what happens with the Ram. I was surprised that it had a 3.6 liter V6 driving the generator. So maybe they figured out a way to have enough power, enough engine power to drive a bigger generator to where that doesn't happen, but we'll see.
Mm-hmm. Yeah.
Interesting. Yeah, that would be odd if there was like a V8, just like the idea of like a V8 plug-in hybrid, but yeah. I don't know.
Not connected strange. To the drive shaft at all, literally just powering a generator. It seems like an excessive size for a generator.
It does, but if people are going to be, towing whatever they feel like and need to feel like they need to drive 80 miles an hour up a mountain pass while towing, then they'll complain if it doesn't perform. I mentioned that you don't need both drive units to bring you down the road, drive you down the road. We have a Tesla Model S, the P100D, that we bought brand new here at the school in 2018. And when it came out, it had a driving range of about 300 miles for a 100 kilowatt hour battery. So that's only 3 miles per kilowatt hour, which isn't very good. But then about a year later, they came out with a software update and increased the driving range up to 370 miles. And it took us a little bit to figure it out, but what they did is they quit driving around with both drive units on. They have this large, powerful drive unit in the rear that they shut off if you go to chill mode, you're not running on the rear motor. You're a front-wheel drive Tesla Model S. And so you're driving around on this smaller, only 350 horsepower front drive unit, and nobody knows, but it's more efficient. And the one thing that I've been a little disappointed with is not everybody has picked up on that. We've got a Ford Lightning here, a Ford Mustang Mach-E, they're both driving on full electric power all the time, both drive units, which doesn't help their driving range. There's the Kia Hyundai products that are out. They have the ability to disconnect the front drive unit with a physical coupler. It like a front wheel or like the front axle of a full size pickup truck can disconnect an axle shaft on one side. That's what they're doing to disconnect the drive units. And then on Teslas, they have a permanent magnet motor in the rear and an induction motor in the front. And they turn off the induction motor because it can free spin without magnetic losses until you need it, and then it just turns back on. No need to have a mechanical coupler to engage or disengage the system. So that's another thing that I've noticed is, and I see that on these Chevrolet, the Blazer and the Equinox and Cadillac Lyriq, they are not running on both motors all the time. So people are slowly learning. But it's very interesting to see the differences and pick up on these little things as we research these.
Yeah, that's so fascinating. Would you say that Tesla is probably one of the fastest learning automakers, at least here in the United States, that you've seen?
It's hard not to like them. Yes. And it's interesting. You know, people have their opinions of Elon Musk and Tesla and what he does or doesn't do. And I teach these 5-day hands-on classes here. And I typically have 24 to 32 students in these from all over the world, all over the country. And I joke with them on the first day. I say, I don't care what your opinion is of Tesla. By Friday, you'll have a different opinion of Tesla. And it's true almost every class. You can't help but do a comparison because we do worksheets on every one of these vehicles on 7 different systems. And by the end of the week, almost everybody is just totally blown away by what Tesla has done versus what everybody else has done. It's like they're years ahead. Yeah.
Yeah. And the engineering speaks for itself to some extent.
It's amazing.
Yeah. Well, that's kind of the thing, because like there's like obviously like stereotypes with like Tesla drivers and stuff, but it's like the cars are so advanced, especially in the used market. Like I recently bought a used Model 3 for around $20,000, and it's like 2021, and it's like the amount of technology in that car for the price is like you can't compare it to really anything else for the value.
Yeah.
So it's truly, it's incredible how far advanced, and like even going to the app, like the app on the Tesla phone is just like so much functionality. I can like
quick
right now on my phone. Quick responding. I can
if I use my Chevrolet app, it's like I got to wait 2 minutes for it to make a phone call and connect, and then it might unlock the door.
Depending on how it feels. And then you got to pay like 35. It's like, I forgot what the fee is. And it's like, you got to pay for the Chevrolet app, and it's like not even that good. So yeah, it's really interesting. But now from some other automakers, is there any really interesting like for instance, like Kia EV6 and our eGMP vehicles, I should just rather say, like with their 800 volt tech charging 800 volt battery architecture. Do you have any like overarching thoughts on that? Because at least in my experience, I've charged both Teslas and Kias and Hyundais, and like the Kia charging experience is incredible. Like it will hold 200 kilowatts to like around 60%, which I think is pretty amazing. Yeah.
Yeah. Well, that's another area where there's been a lot of advances and changes, and that in thermal management of the battery. You can't charge any faster than you can. Well, you don't want to exceed a certain temperature as you're charging the battery. And so, for example, on my Cybertruck over here, I have higher current going into the battery on a 400 volt charge than I would have on an 800 volt charge. And higher current is going to give you higher heat energy. And so you'll be able to charge it at a higher kilowatt rating with 800 volts without putting the high current in. You're doubling the voltage, and so your power doubles by doubling the voltage if you kept the same current. Well, you don't have to double if you double the voltage, you don't have to stick with the same current. You can reduce the current, which is exactly what Kia and Tesla, or Kia, Hyundai, and Tesla are doing with their 800-volt systems on the Cybertruck and on the Kia Hyundais. We're expecting a EV9 here any day, so I can't wait to dive into that. But um, I'm very interested in seeing the 800-volt systems and the differences between them, safety related too. I mean, I teach classes on how to work on and diagnose and repair these systems. So what's different at 800 volts versus 400 or whatever? So um,
Interesting.
there's
Yeah, because
a lot of complexities there.
Yeah, because I think one other thing I've noted, like I was reading about the Equinox EV, and that car has like a nominal battery voltage of like 288 volts. So I was like doing the math on that. I'm like, you need so much current to come out of the EVSC to charge that car versus even
Yes.
like a car that has like a nominal voltage of like 380 or like 400 volts. And I was like, that's
Yes.
really interesting. And
Right.
that probably explains why the charge curve on that car, or probably one of the reasons that signifies like why the charge curve on it's like really not
Yes.
good.
Yeah. And people don't realize that different battery sizes are going to take different amounts of time to charge. You can't say, well, my car charges from 10 to 80% in 15 minutes, and expect a car with a larger battery to charge in the same 15 minutes. It's like, well, you're charging a battery that's twice as big. It's going to take a little longer.
Yeah, those Hummer
Yeah.
EVs.
Yeah.
They take a while.
Yeah. I mean, they might have a high kilowatt hour rating as they're charging, but it's still going to take a long time. It's fun to watch and experiment with. We actually have a DC fast charger here on campus. It's only a 50 kilowatt one, but you can still see and learn a lot as a student playing with something that's even that low of power. But it's fun to watch how when you plug in or pre-plan for or precondition, or watch the vehicle precondition the battery and how much power that's using, and what's going on with all of that would take place at the higher currents there also.
Yeah. Interesting. Now, since we're just approaching around the hour mark, I wanted to end this with two questions. And the first one is, what EV would you recommend to someone? Someone's like, hey, I'm looking to buy an electric car. You have so much experience tearing down these vehicles. You know them inside and out. What is your recommendation? Let's give like a few options. Someone's looking for a crossover that doesn't cost a lot of money, or not ridiculously, not like we'll exclude like the Audi e-tron, all those.
Yeah,
But
yeah,
someone's
yeah.
looking for a crossover, and then someone's just looking for maybe a sedan, hatchback, something like that. What would be your recommendation?
Well, depending on your budget and what you're using it for, I would want to find out how are they going to use it. The Chevrolet Bolt, as I mentioned, it is a really good car, especially for its time, and they're very inexpensive. So for a
Yeah, 10 to
hatchback,
15 used.
yeah, that's a great car. Almost all of them have a new battery because of the battery recall that took place a couple of years ago. Um, so that's for an inexpensive electric vehicle that'll still get you a couple hundred miles. That one's really hard to beat. If you're looking at new cars, um, there's it's hard. Well, for a SUV, we've got a Blazer EV on order, and I wouldn't have ordered that if I didn't think it had some good promise to it. So the Blazer, the Equinox, uh, vehicles in that price range, but they still have, depending on how you use them and how far you think you need to drive in a day, it may or may not work for you. But they're all there in that same price point as, say, a long range Tesla Model 3 that you can get pretty inexpensively. Um, there what was the other category?
Crossover or sedan.
Well, we
Sedan.
kind of covered hatchbacks with the Bolt because I agree. I think the Bolt is
Yeah,
just
we
a
did.
great used deal. But yeah, because I think, and then maybe I was kind of thinking more in, well, and I guess that's the other thing too, like use cases. It's like I've complained about the Subaru Solterra, it doesn't charge that fast, all that stuff. But for someone, if their commute's like 30 miles round trip and they maybe
Yeah, it
live in
worked
like a
fine.
colder area and they
Yeah,
need something with good ground clearance, it's like Subaru Solterra is probably a perfect car for them. But then for
right.
someone who's like, yeah, every weekend we do like a 400-mile road trip, it's like, okay, you
Yeah,
probably need
yeah.
Tesla Model Y or something.
Right. Yeah. Yeah,
And I think,
that's a good point.
and one of the other questions is for you as an educator, obviously with like everyone in this space, it's all this stuff we're very curious to learn about, but like telling this to some person who's probably not familiar with like all these technical nomenclature, all this technology, it's like, how do you go about telling this to someone? Because it's not like you go to a car dealership, I'm looking for something with 30 miles per gallon. It has enough space for my family. And now it's like someone's like charge curves, like battery voltage, all this. And it's just like, it might seem very far over their head. So how would you approach telling this information to someone who's maybe not that technically savvy?
Well, I wish there was just some quick, easy way to explain all the nuances and things to be aware of and the differences between these vehicles. I think a lot of people think that all EVs are the same, so let's just get the least expensive one. And you're going to run into problems if you do that. And so I try to explain the differences in efficiencies and differences in thermal management. We try to figure out, well, as I mentioned before, how are they going to use the vehicle? If it's a commuter vehicle, you've got all kinds of really good options that are fairly inexpensive. If you think you need to go on long road trips or haul a lot of a load, then that's another discussion. But I I don't have a good way. I don't have a good quick way to tell somebody what to buy um, and why. It always involves some sort of a discussion. Um, I've got a lot of Nissan Leaf people that are upset with me because I don't like the Leaf very well because it has a horrible thermal management system or doesn't have a thermal management system at
Yeah.
all. Uh, and but I have people that live places where it's like 70 degrees year round and they don't need a thermal management system for the most part, and they say it works fine for them. But
Yeah.
it, it, I would have, well, without taking up a whole bunch of time, I would try to point them to vehicles that I think have a good overall system, and a good overall system to me is one that has a heat pump, one that has a liquid cooled battery, not refrigerated, um, one that is a one that's been around a while. I personally wouldn't just jump onto some new brand that is coming out. That's You're just asking for trouble. And the first year of any new product is always the worst one. The second and third always get better after that. But you got to do some homework, do some research, and we as a educational industry and the automotive industry need to do a lot better job of trying to educate the potential drivers and purchasers of these vehicles, because unless we can reduce some of the anxieties and worries that they have, then they're going to want to stick to what they're familiar with. And EVs aren't for everyone in every situation, but they certainly work very well for a lot of people.
Totally agree. I think that was a great way to wrap up this episode. Thank you very much. It was a pleasure having you on the podcast, and I'd like to do this again because there's so many more questions in the back of my mind that I probably should have written down. But I learned a
Yeah.
lot from you today. And for people who are interested in joining your EV bootcamp, is there a link or any way you can share how to get involved?
Um, there is a link. I don't have it.
We can post it in the comments.
Yeah, it's for
Online.
anybody.
Okay.
Two
And then
online
two online.
prerequisites before you come so that you're ready. You get all the safety and understanding of the basic systems before you come and put your hands on it. So, yeah, I'd appreciate that.
All right.
Very cool.
I'd like to check that out. So I will let you know. Without further ado, thank you very much.
You bet. Nice to meet both of you.
Likewise.